Okay, so one of the first exercises that we want to learn in this rational universe is what we call a prime factorization of a number, and this is actually very useful not just in the rational universe, but in when you get into the subject of algebra, it's going to become extremely useful. So we're going to classify a number as either prime or composite. Prime or composite. Prime simply means that a number can divide only by itself and 1. So an example of a prime number would be, say, 3, because it could only be divisible by 3, it could only be divisible by 1. Or, say, 5 would also be considered prime, 7 would be considered prime, 11 would be considered prime. However, 6 is not considered prime, and anything not prime would be composite. So not prime would considered to be composite. And 6 would not fit this category because 6 can divide by 1 evenly, 6 can divide by 6 evenly, but 6 can also be divisible by 2. And because it can be divisible by 2, then it is considered composite. All right, so going through the list of the first 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, we're going to go through it and say whether the number is either composite or prime. 1 is prime because it could only be divisible by 1 or itself. 2 is prime because it could only divide by 1 or 2. 3 is prime because it could only divide by 1 and 3. 4 is composite. Now, why is 4 composite? Because it can be divisible by 1, it can be divisible by 4, but 4 also divides by 2. So this is composite. Okay? And again, 4 divides by 1 evenly, 4 divides by 4 evenly, but 4 also divides by 2 evenly. So that's what makes it composite. 5 is prime because it could only divide by 1 and 5. 6 is composite, and we showed a while ago, but we'll list it again. 6 divides by 1, 6 divides by 6, but 6 also divides by 2. In fact, it also divides by 3. 7 is prime. 8 is composite. In fact, after 2, any even number is now going to be considered composite because it will be divisible by 2. 9 is also composite because it divides by 1, by 9, and by 3. And then 10 is composite. Okay, so we're going to focus on this prime, and this prime. That's going to be our main focus. And what we want to do is we want to turn any kind of number into a product of its primes. For example, let's say we were talking about, say, the number 15. Now, the number 15 is not a prime number, it's a composite number, but we can rewrite this as a product of its primes. So what's a number that divides into 15 besides 1 and 15? 3. 3 times what gives me 15? 3 times 5. And so anytime that I'm doing what's called the factor tree, anytime that I hit a prime number, what I'm going to do is I'm going to circle it. And so I'm going to rewrite 15 as the product of two primes. 3 times 5 is the same thing as 15. Now, what about a number such as 20? Well, again, I'm going to focus on the 2, 3, or 5 and see if any of these go into 20, which I know 2 does. So we'll say 2 times 10. 2 is prime, but 10 is not. So I have to keep the process going. So 10 is not going to be 2 times 5. 2 is prime and 5 is prime. And so now that they're done, I could say this is the same thing as 2 times 5. And that is my prime factorization. So here's a couple of exercises for you to try. Try to do the prime factorization of, we'll say, 36, the prime factorization of 42, the prime factorization of 100, and say the prime factorization of, we'll say, 46. This one's going to be a little bit tough, but it can be done. And so the only thing that I'm asking you to do is to turn these into a factor tree. And so your results should look something like this.